Anyway, so this session is now live and people are watching us, so
let's get started, I guess. So people will always drop in anyway, but that's good. Hey, thanks. My name is Janne Heino. I'm the founder and the head architect today for Nest. And we kind of a little bit go shortly through what that it is. And with me, I have Timo as well here.
And we might even say a few words, a few slides forward, but yes, so let's get started.
Yeah, it's like my slides are totally messed up because my screen and my second screen is totally in wrong order at the moment. So I start clicking in the wrong place all the time. Yeah, so I'm kind of like I'm heading the Nest, which is a kind of Nokia private cloud. Just kind of wondering what it is. I kind of like will tell the kind of the story there and in a second. And then how it kind of affects the Talos and the Kubernetes in that story as well. Was happy there in it, like I used the word found there as well. I mean, kind of I started this spring, nice beautiful spring day about 14, 15 years ago. I don't remember exactly anymore when, but it's been a long time. I have a this married for 25 years, technical full technical education, but had the shameful past of being in the software sales for 10 years in my youth when I didn't know better, until I moved to I don't know if I'm anyway doing technical today, but at least people might think that I am sometimes. But yeah, I've been running the Nest development and architecture and production for about 15 years.
Sure. And hi, everyone. My name is Timo Hakas. I'm currently working as the chief architect and being one of the founders of Kumorian. So we've been working with Janne and the Nest team for, since 2011, so quite a while. And basically, I've got a technical background, so I've been developing and building systems and basically implementing what Janne figures out they need or they want to get done.
Yeah, we have this beautiful relationship that I imagine that if the world would be like that, then Timo tells me that maybe it could work out, and the next day I have sold it to a few customers. So that's been our story, one of the basis of the success as well. But yeah, I mean, these are a little bit great. All right, but my kind of story started like about 2010, and it's like in a beautiful summer day. I mean, spring day like today, and basically kind of from the point that I don't know if you have ever been in large corporations, but I kind of came to Nokia 2007 or something, and I've been on small companies before that, and for a few years I kind of enjoyed the space of maybe a different type of environment, but I realized that I've been sitting kind of 2008 and 2009 in meetings without actually knowing why I'm there for the most part. And then I kind of figured out that what if I just don't go to meetings anymore? So what happens if I'm not there? And I realized after a very short time that nothing happens if I'm not there. So I went skiing, I went, having sports, whatever, but after a few months, I kind of figured out that eventually somebody will figure out that I have not actually, done anything for the last, 2 months, give and take. And I kind of figured out that we need to do something better. We're sitting with my friend of mine on a terrace and having a beer, and it's like, well, the cloud sounds like a nice thing to do. Should we, do something about it? Went to my boss and said that, well, I don't know anything about it, but I probably will fail very fast. But I will promise to learn something. And well, that was 15 years ago. We have failed, but we have also learned very fast. And kind of that start of the topic, I always said like we were kind of really much like a small startup within a very large company, working with our own rules and own ways of doing stuff. And it really started with that, free servers in the beginning. So that's kind of what I went to another friend of mine to get, and we did that, and then then we sold that to a couple users, and then with other ones, and then it just kept on growing as the numbers kind of like see that we grow even in the first couple of years to 1,000 cores. That was the moment when we kind of started to evaluate different options and went to a lot of well, I think like the last kind of speaker was saying that like working with small companies, and that's what I've done most of my kind of career as well in here. So we went to a lot of the large companies in the 2011 to ask about cloud, and what only we got was PowerPoint. With this beautiful PowerPoint, a lot of PowerPoints. I think from one of them we got 64 different PowerPoint sets. How beautifully it works. But then when we tried to install it, well, after 2 weeks, there was no hope. So we kind of realized, okay, this doesn't work that way, and we kind of stayed on that road. We run with eucalyptus for the last, I think, first 5-6 years, and we grew to that 55,000 cores, kind of size wise. That's about at that time it was about 40 racks of space, maybe a little bit less. But then really that was a time when we kind of got caught up with the next generation of 5G development. The kind of like our first critical use cases came already 2013, when we kind of started to be critical to business, let's say like that. But we were not officially the primary target of running something yet. But then 2014, 15, the change happened that we became suddenly the kind of the only place where people started to run their development. So all the builds and software development started to happen on top of our cloud at that moment. And as you can see, the numbers started to grow like crazy. So we grew in a couple of years from 50 to 400,000 cores. And we kind of have never stopped since. I mean, the numbers kind of like slow down the speed in a sense. We are now at 700,000 cores. So it's about 350 racks what we have worldwide, and in our full size racks what we are running in our 7 data centers around the world. So we are medium size hardware house in a sense as well. So I think we have about 11,000 servers give and take today. But the kind of like the critical part kind of in the story happened, I think we don't fully agree with Timo, was it 2018 or 19? But that was the time when we kind of have first had the look on running Kubernetes as a service. So before that, we been running eucalyptus and then OpenStack as our platform to provide virtual machines and networking and storage S3 for our users, and various of other kind of critical infrastructure services, which we found out that in a large corporation, or in generally anywhere, when the users came, they break everything we know that it existed before. The DNSs were not meant for use that in that dynamic manner that we were kind of looking for. Repositories where you kind of download packages, they were not thought about it. This happens 1,000 times every morning or 10,000 times every morning, when previously it used to be that there was maybe 500 installations a year. So suddenly there was a huge change in everything what kind of we did, and that caused changes everywhere else. And that was kind of like the problem, that we eventually started to eat everything to ourselves. That, all right, so first it was just the servers and the computes, and it was storages, and it was networks, and it was the DNSs. So over time, everything that we started to do came to us in a sense. But then 2019, I think we had one other crossroad in our head, and we were kind of looking at what we should do to renew, and all always you need to look forward what you're gonna do next. And that moment, Kubernetes was popular. I think it was clear there's gonna be the well, I think those are like the early ones when they really kind of became clear that Kubernetes is gonna be the winner. So we were looking at the moment when it was clear that is it gonna be there was, I guess, the Docker enterprises were there, and the Marathon and the kind of other topics were there at the moment still. But then it started when it came out that okay, all the public cloud vendors started to support Kubernetes. That all right, that's the way that we want to go. I think it took us about maybe 9 months to get something out, and then maybe other 9 months to get something in real production.
Well, I guess it was around 15 months to GA, but we had the first POC users in 3 months or so.
Yeah. That's also very, very what we always been doing. So get something out as fast as you can, and then work with those critical first users as hard as you can to make sure you fit their needs. But yeah, I mean, that was kind of like, and it was surprisingly, I would say, kind of slow start in a sense what we were maybe what I would expect in the first place. That all right, in 2009, we kind of got those early adopters in. But then, I think in 2021, we still had maybe 20,000 cores in Kubernetes. So it was kind of growing, but kind of expected to grow faster. But it was kind of like a typical thing that our largest customers and all of them, they were developing their solutions. They were moving their stuff slowly to the kind of Kubernetes part, and doing that as a kind of, it took some time from them. But then last year it really exploded for us. So we kind of went from that 10,000 to 130,000 cores in a year, give and take. So it really grew like exponentially, because then suddenly all of those large users, instead of running somewhere else, they all would take production workloads, all of them, from the kind of current virtual machine environments, move them to the kind of Kubernetes. So it exploded extremely fast as we were going. Now, maybe kind of just from our point, what we see is the next phase really is going to be that kind of we have been increasing our PaaS services, so database as a service, and actually we are running our database as a service on top of Talos today. We are running our Kubernetes GPU services on top of Talos today. So I guess we work there together for 6-9 months together to make sure that we kind of get those pesky NVIDIA drivers into the kernels, and the rest, so that we can actually kind of run it properly. But we have now, I think, a couple racks of pure GPUs running Talos as well, and giving that to the end users as services in there. So kind of this is just going to be kind of going forward, harder and harder. I think that maybe next year is going to be that 300,000 cores where we are. Just shortly, kind of like, so we do private cloud. We are part of Nokia, so we do everything that happens from phone to kind of the network and back topics, so to get you connected. We have hybrid cloud offerings as well, of course, so not everything we do ourselves, security and other services. That was the officially kind of cloud slide that I have to show. But yeah, we have today about 720,000 cores, 50 petabytes. As I said, about 11,000 devices. So it's a kind of various servers and some network devices there. Everything we have is running on open source. So that's kind of been always the thing that everything is there, running there. Give and take, 5,000 different projects. So it's about, nowadays it's mainly still maybe 70% is various of CI, and testing processes. Remember, in a telecom industry, those can be quite interesting. They are not all your traditional testing. They can be very, very interesting. Somebody tries to run your networking within network simulations underneath us and stuff like that. But that's kind of very different from there. But yeah, that's kind of where we are. There's a couple of things that are like on a bridge to Timo, in a sense, that kind of why as well. So one topic is that when we kind of do this, so when things scale, they break. I mean, I haven't had a single solution that hasn't broken this far. When our end users get in, they break. They break them one way or another. When you get more, scale, things start breaking in a way that you didn't think that they could. So monitoring automation there becomes kind of critical. End users are really interesting. They've always find a way to break your things. That's kind of like, well, then you need to make sure that you kind of keep a good relationship with the key guys there. But also they will find ways to do that. So what we have found out on the way from kind of early on, maybe 2013, is that the only way to do this is automation, and it's the only way for us to keep the kind of the quality and the cost into something that we can be competitive. So that we always try to automate everything we can, and kind of taking that kind of like a level higher and higher as we go. And the other kind of like last like kind of comment there is really that the adoption curve is critical to understand that, you know, when that's gonna be hitting, that you need to be ready for it. So it kind of like ties up into that last topic. So, you know, experience is something you cannot rush, or, you know, I don't think there's even better saying that you cannot kind of squeeze that somehow. But the point there really is that if those years that we, you know, had there early on, that, you know, we had a couple of years when we have 1,000 cores, 7,000 cores, you know, so why didn't we just start doing this later? It's like, yeah, but we couldn't, because we wouldn't have been able to be ready to do for that scale. So it takes a few years of pain before you can actually also be ready for that larger scale production there. And some of those results, I guess, is what Timo is going to be explaining now on our Kubernetes side. And then actually Kai from my team is going to be also talking about the more technical details of how we are running this on Talos later. But Timo, go ahead.
Okay, cool. Did the presentation switch over? If so, then I think we can.
Not yet. Let me give a second. And I find my mouse again, which is on the wrong screen. All right.
Okay, so are we on NKS already? So let's very quickly brief kind of what's the service that we are providing to our end users. So we are actually giving them managed Kubernetes clusters, similar to what most of the public clouds do. We did have a long discussion on whether we aim for large multi-tenant clusters, but at the end of the day, many of the internal users are larger teams or organizations within the company. And the clusters that we end up running are actually fairly large, as you'll see in a minute. Nowadays, we provide two different deployment models. We talk about NKS-V and NKS-M. So there's the virtual one, which for us means OpenStack, and bare metal obviously is Sidero metal-based pure hardware servers. And we try to run by the shared responsibility model, again, similar to what you have on the public cloud. So the NKS Nest side, we take responsibility for making sure that the infrastructure gets provisioned, your servers, whether it's virtual machines or bare metal servers, are monitored. If something breaks and when something breaks at this scale, it's automatically repaired. And you kind of can focus on running your workloads. And we also provide the upgrades for Kubernetes and any other pre-installed services, such as logging, monitoring, or IAM related ones that we typically pre-bundle with all the clusters we provide. And when you get a cluster from us, well, you are responsible for the user management. So how do you want to segregate the internal users and teams, the namespaces, service accounts, anything you deploy into the cluster? That's your responsibility. So obviously, in certain cases, we do cooperate and we need to figure out if something goes wrong, but the normal split is this. If we then look at the numbers, so on the production side, today we've got around 320 clusters. The total cores, well, this is the non-inflated. I think Janne had the sales guy hat on and he was saying 130K. I think it's somewhere between 120 and 130K in reality, but still a fair amount of the total capacity that we have. For nodes, on the VM side, 5,500 nodes, bare metal servers. The bare metal service was launched a bit later, but still nice amounts of servers fully dedicated to the bare metal service. Our oldest production cluster is 3.4 years old, and I think that's pretty much the same as when we went GA. So we have many of the first GA customers still using the same clusters, and they've gone through quite a few iterations of upgrades and maintenance on their clusters. We've got some smaller test clusters. So for us, small means 20 or 30 cores, so around 6 or 7 nodes on the VM side. But the largest ones, so on virtual, I think the largest cluster is a little shy of 6,500, and on bare metal, it's 11,000 cores. And we just did a quick snapshot sometime end of last week on a typical amount of workloads, so 55,000 pods running in the environments. Actually, a bit less than what I was expecting when you consider the amount of nodes that we have, but there are some really, really large workloads also running on the build environments. And we've been very, very lucky so far. So unrepairable, totally lost clusters, we haven't had any of those. We've had a few kind of close calls when we lose a single or a second of the control plane and then do something else to lose the full control plane. But luckily, we know that recovery through backups is possible and kind of nothing is fully lost. So we haven't had any proper bad incidents at all. Technology tooling. So at the time when we started our journey, because it was one of the meetings, internal meetings, and Janne said, let's do something with Kubernetes. And we hadn't used it too much. We had experimented a bit with Mesos and CoreOS, but it was quite new to us. So what we started putting together was kind of what we knew and what was familiar for us. If we do it again, we might do it slightly differently, but it's worked out quite well in the long run. So we do have quite a bit of custom code. So we've got an API server, which is Node.js and TypeScript based. There's a CLI and quite a few additional services. And nowadays, most of those are in Go, but a few services are also in Python. On the bare metal side, where we actually need a proper inventory for the servers and related networking components, we're using Netbox for that. For infrastructure management, Sidero, obviously Sidero Metal is the way for us. And on the virtual side, we've gone with Terraform. And this was when we were launching, we had a look at the OpenStack CAPI provider. We didn't have too much success at the time. So that's kind of why we went down this route. And for automation, so obviously in addition to custom code, we're using quite a few of the normal tools. So Ansible and AWX for automation and Terraform for various other parts. And for deployment, we're using Argo CD. We're working out fairly nicely for us. The data stores is probably interesting for some. So we went with XD for config management, similar to what you'd get for a normal Kubernetes cluster. And it's worked really nicely with the bigger clusters and using the operator for managing it. We store all the credentials and keys in HashiCorp's Vault, which is actually also using XD as the backend, which has been very easy on the backup side to get a single backup that pretty much gets and stores everything that you need on the master cluster side. We also use Redis for caching and pod-to-pod communications, and there's a lot of S3 use for the backups and also kind of other longer-term log storage and events related to cluster activity. There's also OpenSearch and kind of logging related, monitoring related separate systems, but I'm not kind of targeting or discussing those here. When we talk about our deployments, we typically talk about data center specific ones. So in most cases, it's the same setup for any larger region that has one or more data centers, but the same setup can also be used in edge rack deployments. So we've got a few deployments for external customers and also for internal use cases where it's a separate 1 or 2 edge rack deployment. So we have one Kubernetes cluster for the NKS master, so which runs the API that we've written and all the data stores. Then we've got one which is the monitoring cluster, which basically acts as the single point scraping metrics data from all the customer clusters. And then one or more customer clusters. So the NKS master is responsible for the provisioning and keeping those in sync and doing the upgrades for those. A few words on the NKS API. So we provide a basic REST API for integration with other systems, and for the ops and supports engineers, they use our CLI called NKS CTL. Which provides all the main operations needed to kind of work with the amount of clusters that we have. NKS supports a number of different infrastructure types, mainly the virtualized OpenStack environments and bare metal provided by Sidero Metal. And we also provide support for a number of Kubernetes provisioners, Talos being the default one. Both for our master clusters and all the customer clusters. We've done a bit of experimentation with Anthos and OpenShift due to interest within Nokia. Some teams have a reason to consider those, but for us at this scale, Talos is the main option that we always kind of default to. The operations provided by the API, so the core functionality is basically CRUD for cluster management. And similar to what Cluster API has, we have fairly detailed specifications. We talk about cluster specification on what sort of cluster to create. So you can define multiple different groups of nodes. We can utilize different rules for affinity, anti-affinity, soft or hard. What are the instance types for different nodes based on role, GPUs, these sort of things. And there's also customization options. So you can enable various feature gates, configure lower level sysctl config settings for enable swap and other options. Most of the other functionality is around the auto repair and detailed debug information. So if a cluster is running, how to kind of see what sort of automation we do for the infra management. So this includes things like making sure that the security groups are as expected. We've got certain parameters that are kind of auto accepted if there's a configuration change, but otherwise everything kind of is mapped exactly to how it should be. So the changes are rather kind of if we do incremental upgrades to the clusters and the security groups, for instance, that related to those. And then there's a lot of internal account-related, group deputy-related configuration, account quotas, and these sort of things that typically come into play when you're dealing with hundreds and thousands of accounts. This is just the picture isn't the most descriptive, but to keep the outside view understandable on kind of what's happening in the clusters, we're actually utilizing a state machine. So, and as an example for a new cluster, we start in the uninitialized state and get an event in for creating the cluster. We then run through various steps of provisioning the accounts and quota, doing infrastructure, provisioning Kubernetes, provisioning storage, doing post-provisioning tasks, and installing the additional services into the cluster, eventually ending up in cluster ready state. And then we run basically a control loop of checking the cluster and the nodes and Kubernetes that everything is working fine. And if not, then we rerun the applicable steps of fixing the infra or fixing Kubernetes. A few words on the automations that Janne mentioned, and kind of things that we need to try to keep running. So we have two types of upgrades. There's the Kubernetes upgrades. So we mainly focus on the going from one major release to another one. And then there's the minor NKS service specific upgrades, which means configuration changes to the clusters, newer versions of the pre-installed services, and so on. So for Kubernetes upgrades, we try to stick with the 3 upgrades a year. And typically we're kind of 2 releases behind what's the latest and greatest from Kubernetes to have something that's stable that we can run and kind of have enough bug fixes available. For NKS, every commit into a repo results in a release, but we're currently still selecting the releases that get deployed onto all of the clusters. And we're looking at improving this so the customers would have full control over when they get the Kubernetes upgrades, being able to select the upgrade schedules and manage auto upgrades. We also already have implementations of the intelligent upgrade that Kai might mention in his speech, but being able for the end users to participate in the upgrade process so they have a better view into when nodes are getting upgraded and they can perform pre and post activities when the upgrades are happening. A few other things, like I mentioned, we utilize a bunch of external services such as AWX, which is the open source Ansible tower, for automating things also from the outside. So this is an example. All the clusters internally capture their metadata and store them in S3. So there's typically like a Kubernetes cron job or something similar for catching data that needs to be stored at a different location. We then rely on an external verification job from AWX, for instance, to make sure that the backups do arrive as expected and are valid according to certain rules. And this has worked really well. Like I said, we haven't had issues with losing any of the clusters. I guess we're ready for the Q&A session.
Yeah, sorry, I've been answering some of them as they have been coming. So.
Yeah, I was going to say Janne's been typing away. About Rook and Ceph.
Yeah, that was maybe a little bit unrelated discussion in a sense, but yeah, I mean that's where we run our storage. But yeah, we run it on a fully separate racks. Today is running traditionally on CentOS-based Ceph environments, but and it's mainly on our DevOps team. They really appreciates the kind of ability to not to screw up that easily. Or to have the full control of what happens. So Ceph is a kind of notoriously difficult if you start moving stuff around, and sometimes the Kubernetes operators are a bit optimistic on understanding the size of a cluster when you have 100 terabytes of data per node. So they just sometimes make decisions that, hey, I want to move this stuff from the one server to another, and then they don't realize that might take a day or half. They just work in their lab where it takes 5 seconds, and it's up and running. So it's a little bit different from that approach. And the kind of other one, yeah, we couldn't run it we have really like looked at it a few times to run it for our end users within the clusters, but the end users have so much of power what they can do there that I don't know how we would be able to safely run the Ceph there, because even sometimes they run too much there, and our monitoring and other tools stop working because they want to run them at 99.9%, and so it will be very difficult to do that efficiently.
Yeah, so I would like to ask, what is Nokia's view of running on Talos compared to other operating systems? Like, how did you end up on Talos?
Well, I think the story really was pretty much what we heard in the previous one, that when we were looking at that we had two reasons. One, at that point we were looking at running on bare metal. So security was one crucial topic, that hey, we want to make sure that the footprint and the accessibility of those servers is as minimal as possible, and we can run those on safely. The other reason was really then that topic that we need to make sure that I wanted to kind of like the idea that it doesn't do anything else. We've been kind of very traditionally running Red Hat and CentOS before that, and you have huge amount of packages, huge amount of services. But if you're running only Kubernetes, why would you have all that? It was interesting when you said in the opening that, hey, we want to still reduce the amount that was running. It's like, we went from 1,000 to a 10, when we moved to Talos. So if we reduce some, great, but it's already kind of moving from the elephant to a small dog. When we move to Talos, it's faster and it's lighter. It does what it's supposed to, and not something else.
Yeah.
It makes it also better, faster. And some of those, by the way, what the kind of previous session numbers on latency, I know that they were not referring to internal, but we see that as well in internally, that when we are running Talos, it's very efficient on because it reduces the overhead away from us pretty much everywhere. So it's been that's been the major reason.
Great, thanks. Got a question. Can you compare your one core from thousands of cores to 1.6 gigahertz ARM Cortex or another one?
No, I can't. And I think those are very difficult. We have done comparisons, not to ARM, but to other, like Amazon and other cores. But it's everything is so much, relative. What are you running on, and it doesn't really matter what you're running on, and is it CPU intensive or memory, or what's the kind of point? But we've been doing kind of comparisons towards public cloud vendors in general, and our cost structure is about a third, give and take. That's what our kind of environments cost. And that's why we are kind of right here. And otherwise, why wouldn't we use just the public cloud for all of our stuff?
And that's counting in all the costs of operating your data centers and everything?
All costs. Yeah.
Great. Cool.
So we have about 150 people, give and take, today to do the operations, development, everything around that. So we are in the size that we can run things efficiently. Like we have our own data centers, or we'll be running Equinix data centers. I guess the next one was Equinix, if I remember right. So we have stuff running on Equinix data centers, but we take the white space, we build it ourselves, and that's it. And then kind of but we are big enough that we can take the kind of assumption that each server is not critical. If the server breaks, we don't care. So you take the next one from the rack or the row. So we can live with the same kind of ideology that I don't need 24/7, for all of my topics. I can just live with the capacity, and that kind of all of those topics lower our cost in a sense. Yeah, I mean, like all of the stuff what we have is open source. We run on OpenStack, we run on Talos, we run on Ceph. All the pieces what we, AWX, kind of everything we were running, even Vault is open, the open source version today. So everything what we do is kind of open source. Do we open source our stack forward? It is kind of open source. It's just a kind of a netbox. They all what we run are open source tools. What we have done is to integrate them to each other. But they are a little bit. I think that they would be a bit unique to be able to utilize somewhere else. It's not that easy as that. Our roadmap. I kind of referred to it a little bit in the earlier. So it's services. So we have the database as a service. GPUs came out this year. Timo's biggest problem right now is making Vault as a service for our end users. That's also running on. Oh, that is not running on Talos, by the way. I guess not. That is not
yet. No.
Not yet. No. But yeah. So that's what's coming. So it's services explosion in a sense. It could be the way that we have a lot of more new services coming up for our end users. So the PaaS world has kind of finally come in the private cloud as well. If we can offer those with reasonable cost to our end users and all.
I guess the internal development teams aren't that massive, so we've got around 4 or 5 people working on AKS related things.
Yeah. Yes. Yeah. We have GPUs. We have a few racks of GPUs. Yes. We have. We are running on a couple of different versions of NVIDIA GPUs today. Waiting for the new 8 series to come with the new probable problems. But yes, NVIDIA, yes.
On Talos,
yeah. The hundreds and the A100s and A20s we are running today.
Awesome. One more question.
Everybody always asks about the CUDA versioning. If I would remember, I don't remember right now. So yeah, it's
no, unfortunately, neither do I.
Yeah.
So it
Calvin is not here, who is our GPU guy. So yeah, like Kai said, we worked with Talos from beginning. I mean, there to make sure that we get those NVIDIA drivers in. So I guess we were like 6 to 9 months in the discussion, and then after that, kind of we got it nailed down.
How do you manage end users needing to configure these resources like Argo CD if the standard doesn't fit?
Yeah, they are for us mainly, so that they are our platform.
Yeah, we don't really enforce what the end users do in their clusters. So what we were presenting about was kind of how we run the setup to maintain and manage the clusters. So yeah, we use Argo CD internally, works very well for us, and I know many of the users are also using.
No, we don't. Maybe we should. Yeah.
Yeah.
Was that Janne, a promise you'll be writing one? But
yeah, maybe yeah. If you do part of it, yeah.
For people watching, Kai, who's commenting on the GPUs and posting the links, he also works at Nokia.
Yeah. He will be talking later. So great.
That was awesome and right on time. So now we have a 10-minute break. And then we get to come back and hear Equinix's adventures with Talos. But,
all right.
Thanks, Janne. Thanks, Timo. I appreciate it. That was really good.
Thanks, guys.
Bye.